So yeah. All right. So hello, welcome to week 3. Again, there's a smaller class section in person today, probably because of exams. So if you're watching this, I hope you did well on your exams. Um, but yeah, we'll just dive into it today. We're going to be doing a little bit more with kind of sketching and stuff like that. And then we're going to be working on assemblies, which is pretty exciting. So, canvases and assemblies. So yeah, jumping in, we're just going to start with assignment 7, which is just kind of reverse engineering the engineering fountain. Basically, this assignment is kind of here just to show you that you can use things that are in like from the real world and you can reference them in your designs. So Fusion has a function called a canvas where you can insert images into your workspace. So lots of people use that by like maybe taking a photo of something and having some measurement reference. So like maybe you could take a photo of, I don't know, let's say this mouse here, right? And then you could put like a quarter next to it, and then you can kind of use that reference to reverse engineer something. The other thing that people like to do with this is take like a sketch or like a model that you've created on paper and then using that as a reference as well. So people take like images of cars from like the top and side profiles and stuff like that, and then they'll import them to use as a reference when they make stuff. So today we're going to be doing that with the engineering fountain. So yeah, let's just dive right in. So under the resources tab, there should be this nice side photo of the engineering fountain. So we're going to be using this as our reference to make, our interpretation of this structure. So I'm going to go into Fusion. Make sure you download this photo, obviously. And I'm going to import it into our design. So basically to do that, there's this option up here, kind of the top right corner, with this canvas option. It looks like a photo icon. And again, it gives you kind of like this highlight of what this tool does. You see this in this example, someone drew like this side profile of this car, and then they used that as a reference. So we're going to select that. And then we're going to browse files. Find it wherever it is in your file explorer, and then we're going to select a plane. In this case, I'm just going to select this one right here. You can see if I zoom in, we have this engineering fountain on a canvas. And again, we placed it on a plane, so it's 2D, it has no thickness, but we'll use it as a reference. Over here, there's a bunch of different options. You can select things like the canvas opacity, so like how see-through this image is. The default is, I believe, 50, so I'm just going to leave it there, but it's kind of whatever your preference is. And then there's a bunch of scaling stuff. Again, for this assignment, scaling isn't really important, so I'm just going to leave it there. But if you did want to rescale things, this is probably where you would do it. So I'm just happy with that. I'm just going to press OK. We have this nice canvas here that we can reference. And then I'm going to just start making a sketch. Now, similar to the gear assignment that we did last week, where we patterned the teeth of the gear around a circle, we're going to pattern the whole body of the engineering fountain for this assignment. So what we're going to do is we're going to make one part of the engineering fountain, and then we're going to pattern the body around in a circle. So very similar, but a little bit different use case, but it's pretty cool. So just going to create a sketch here. I'm selecting the same plane that the fountain is on, and then I'm going to just start sketching. Now you'll see this photo is like slightly off center, but I mean, I'm not too worried about that just because we're just making one of them. So I'm just gonna trace this one on the right, but if you wanted to trace the one on the left, that's perfectly fine. So what I like to do for this is I just like going straight across and then up for this one. And again, this is not like a perfect like side shot profile, so this angle is like not exactly 90 degrees. But for this assignment, that's okay. We're just kind of eyeballing it. I'm gonna add this line. Let's go here. And then I'll do one vertical line here. So for this curve here, it's actually not exactly a circle. I believe the function at which like this kind of curve is modeled after is the e to the x function. At least that's what I've been told. So we're going to use a fit point spline just to kind of get a nice estimate. Again, circle probably wouldn't work here just because it's not exactly a circle. So fit point spline. And what I'm going to do is I'm going to make a curve that starts at the top here and goes all the way there, and then I'll trim the excess later. So I'm going to start about here, and then I'm going to click my way down. I personally like putting like points at the edges of like these two bodies, so I'm going to make a point here and then make a point here just to make nice points for us to trim later. And then I'm going to click this check mark once I get to the end. Now we have this nice curve. So I'm going to hide the canvas by pressing this little eyeball here. And you can kind of see this is our little foundation that we've created for the fountain. I have these little extra extending lines, but we're going to trim that away. And then we need to add these last two lines here. So using the points that I just talked about earlier, I'm going to draw one there and one there. And again, if I hide the canvas again, you can kind of see we're kind of starting to separate everything, right? There's one spot here, one there, but now we have excess, so we can just trim away with the trim tool. When I do that, there we go. Now we have two separate sections. Obviously, these are unconstrained because I haven't added dimensions. For this assignment, I'm not going to constrain anything, so don't worry about it. But yeah, you should have this. Does anyone need help with this? I went a little bit fast, so if you want me to do it again, like, please raise your hand so I know. Yeah. Yeah, sure. I'll just start from scratch. Oh, the spline? Sure. Okay, I'm gonna delete these two. Obviously, I have these points here already, so I'm gonna use them to create the spline. So the fit point spline tool is right next to the circle tool, and then I'm gonna choose a starting point, which is just the start or the top right here, and I'm just gonna click my way down, kind of following the curve of the fountain. So click my way down here, and then when I get to here, I like choosing the edge of it just so it's easier to trim later. And then I just click all the way down. The other way you could do this is you could just create two separate splines. That's also perfectly okay. This is just like my preference for how I do it, but again, if you like doing it in two splines, that's perfectly fine too. But yeah, I just kind of hide the canvas just so it's easier to see. But if you ever needed to manipulate the spline, there are these kind of green lines here. Those actually aren't part of the line, but it kind of manipulates the angle. So if this was off for whatever reason, you can kind of drag these and you can kind of see how the blue line changes a little bit. Obviously, this isn't really what we want, so I'm just going to leave it, but that's kind of what you can use to manipulate splines. But yeah, I'm going to trim that, and it should be pretty good. I'm just going to walk around for a bit. At least I hope so. Okay, so um, wow, it's lagging. So basically, what we're gonna do is we're just gonna extrude these. I'm gonna extrude it like wrong on purpose, um, just to kind of show you like how things will behave if you extrude things certain ways. Um, so I'm just gonna finish the sketch. It's not constrained, but in this case, it's fine. I'm gonna extrude it with the tool right there. It's going to ask you to select profiles because there's more than one, so you have to specify, and then use like specify some distance. Okay, I'm just going to do one, but you can see I'm choosing one-sided. I'm purposely doing it wrong just so you can see like the differences between how you extrude things. So I'm going to leave it one-sided for now, but we'll see in a minute how that might look different. So we have this like 1/4 of the engineering fountain, right? So we're going to circular pattern it just like we did for the gear assignment. So we're going to go under create, pattern, and circular pattern. In this case, we're selecting bodies instead of like, sketches and stuff like that. So I'm going to select these two bodies, and then it'll ask you to select an axis. In this case, I'm just going to go off one of the ones off the origin, which is this green one. And then I'll specify quantity. The distribution is full just because we want it to be even. But you'll see here, because of the way we extruded it, the fountain isn't exactly like how it looks like in real life. It almost looks like this little pinwheel kind of thing. And that's because of the way we extruded it, right? So we need to make sure, in this case, that we have this extrusion symmetrical, just so it'll center it along the plane that we created it, and then the extrusion will be centered around the axis that we're rotating it around. So I'm going to edit this by going in the timeline and editing the feature. And then instead of one side, I'm going to change it to symmetric. Because of that, you have to change the distance to be half of the one it was before. So I'm going to change it to 0.5. And then when we do that, you can see this is kind of the behavior that we're looking for. So keep that in mind whenever you're making like your extrusions, because at the end of the day, both extrusions are, in this case, like 1 millimeter thick, but where we create that extrusion relative to the plane can affect how your model looks. So yeah. The next thing we're gonna do is we're gonna add kind of like this detailing right here. Oh, okay. We have questions. What's up? Okay, I think everyone is good here. All right, so what's next on the list is to create kind of these details here on the engineering fountain. If we look at the canvas here, there's kind of like this inward cut or like kind of detail on the inside of it. So we're going to try to recreate it. So similar to the other things that we've been talking about, we're going to be doing it once, and then we're going to be having Fusion do it to the rest of the parts. So there's a couple ways you could go about doing it. Basically, I want to make sure that I'm editing the original one and not like one of the ones that we copied. You could do that by just like ensuring it and just selecting it right here. But you can also just move the timeline and hide the parts and then editing this, right? So basically, because we had the circular pattern, pattern the bodies that we created, any edits that we make to the original one before we pattern it will go into the next, go into the ones that we pattern. So we're going to make sure that we edit this one. I'm just going to show you that you can do things out of order and move it later. But if you want to be safe and make sure you're editing the right one, you can also just move the slider. So you just select the original. But I'm going to do it like this, just to kind of show you. I'm going to create a sketch. I'm just going to put it on this face here. I'm going to show the canvas again. And then I'm going to try to recreate some of this geometry. To start, I'm going to copy these lines that we've created on the original extrusion. So basically, I'm going to make sure that these lines, I'm going to reference these lines by basically copying them into the sketch. So you could do that by like drawing the line physically on the piece that you've made, but you can also do it with something called a projection. So projections are pretty nice when you've created some, geometry that you want to reference. So in this case, I kind of want to reference like this edge here and maybe this one along with a couple over here. So we can use projections as like a reference. So if this like were to ever change, the references will kind of follow it, right? So the hotkey for adding a projection is just P for project. And then you choose the geometry you want to project. You can either choose like lines or faces. I'm just gonna select like a face here and then a couple lines here just to show you. But when I press OK, it'll have some lines highlighted in pink. So I'm going to hide the bodies here. You can see here, this was, the face, so it gives you, the closed body. But also, if you just select lines, it'll give you kind of an open area as well. So I'm going to use these as kind of like my boundaries for the details. And I'm just going to create, just a spline here, but you can kind of create whatever you want. Just as long as there's some detail, that's just kind of what we're looking for. Obviously, this isn't like exact to the engineering fountain, but I'll just do my best to make it somewhat close. All right. So I've made this spline here. It looks kind of messy. But you can see now that there's like some closed bodies here, and we can use that to cut it out. Does anyone have any questions about the projections? It's okay if you didn't catch that. All right, sweet. Okay, so we're going to be using these two profiles here to add some detail. I'm going to finish the sketch, and then I'm going to cut these into our original body. So I'm going to go extrude. I'm going to select the profiles that we've just created. I'm going to have them cut in a little bit. You see the operation is set to cut. I'm going to press OK, and then there we go. We have this little detail here. You'll see that it's not on the other side, so we're going to have to add it to that side as well. There's a number of ways you could do that. Again, there's no like one specific way that you have to do it. The two ways I think of doing it is you can just do another extrude and then change the face at which you're extruding it from, or you can do a mirror, right? So I'll do both of them just so you can kind of see. You know, they both have the same final outcome, but depending on your preferences, you might want to choose one or the other. So I'll just first start with the extrude. I'm going to show the sketch that I made before. For the profiles, again, I'm going to select the two that I created earlier, but instead of starting on the profile plane, I'll change it to object, and then I'll click on the opposite face, and then I'll set some distance, right? So I think it was 0.2 on the other one, so I can do that, and then operation to cut, and then when I do that, boom, the features are the same on both sides. So that's one way. This might be a way you might choose if the two distances may not always be the same. So for example, maybe one side is extruded like 0.2 and the other is like 0.5. In this case, they're symmetrical. So personally, I think I would favor the mirror function instead. So if you go create mirror, you can change the type of mirror that we're choosing. In this case, we're doing a feature. And we can select the feature and then do select the mirror plane as that plane that kind of cuts through the symmetric extrusion, right? When we do that, should just cut it identically. So again, there's no right or wrong way to do this. There's just kind of preference. Again, the nice thing is if, for example, I wanted to change this one, it'll change both of them, right? If I change this to 0.3, it'll cut both of them to the same length. If I just did the extrude, I would have to change it twice for them to be identical. So yeah. So you'll see now that, let's call this, this one finished, right? We have the details and all that stuff, but it hasn't been applied to the other ones, at least if you did it after the circular pattern like me. So similar to last week where I moved the shell, I'm going to move the circular pattern to be in front of all the things that we've just created. And when we do that, it applies it to all of the different bodies, right? So again, the order at which you do things can have an effect on your design. I didn't change anything except for the order, so that's just a nice handy tool to have in mind. when you're designing stuff. Does that make sense to everyone? Does anyone need help with this? Does anyone need more time on this? I'm just gonna wrap this one up real quick so we can get on to assemblies. So the last thing on this is just creating a base. So I'm just gonna make one real quick, making it a sketch from the origin, or a circle from the origin, and then another smaller one. I'm just kind of eyeballing this, so I'm gonna finish it and I'm gonna extrude it. For some reason it highlights this as a plane that you have to extrude as well, so I extruded both, or not plane, a face to extrude. Oh, that's a lot. Maybe like there. There. we have our engineering fountain. Everyone good here? Okay, sweet. So now that we have, you know, I'd say a pretty decent understanding of how to create individual parts, we're going to move on to assemblies now. So, you know, for most things that you make aren't just going to be one piece, right? Your computer is made of, you know, hundreds, maybe thousands of components. And, you know, a lot of us sometimes wish that there was a way to put these things together in a virtual environment, right? So we can do that with Fusion by making assemblies. And assemblies are really useful because again, you can create, you know, kind of a virtual representation of the whole thing that you're designing. So it'll help you catch maybe errors that you've made in your design process. It could be like, oh, you know, this piece is like phasing through this piece, like that can't work. Like, then you can edit, you know, the parts to make sure they all fit together nicely. So assemblies are very powerful. So what we're going to do with assemblies is we're going to make some Legos. So we're going to be making this Lego car in an assembly, but obviously you can make basically whatever you want in assemblies. So first, I'm not going to make you CAD all these Lego bricks, so please download this zip file with all the Legos in it, or the Lego bricks, and then unzip the file. If you don't unzip it, then Fusion won't read it. I've already kind of done that already. So I'm going to open up the data panel, which are these, you know, that button, the 9 cubes or squares. For organization's sake, I'm just going to make a new folder. I'm going to enter it, and then I'm going to upload it. So again, I've unzipped the file already, but then you just select all of them, and then you upload them. And it'll take a bit. Raise your hand if you're having trouble accessing the file. I hope not, but sometimes it happens. All right. So to create our assembly, we're obviously going to start by creating a new file. The one difference is that you need to make sure you save the file before you start inserting parts. Typically, when I design stuff, I just make a file and I start going. But for assemblies, you need to make sure it has a name first. So I'm going to save it. I'm going to give it a name. And then we can start adding stuff to it. So for this part, I do recommend you kind of leave your data panel open because you're going to be dragging and dropping these parts into your design. So we're just going to start with the first piece. Personally, I kind of like choosing maybe like either the biggest piece or like a piece that you can kind of see as like the foundation for your part, right? Like for a car, I wouldn't say like the foundation for it would be like the wheel or the tire. I mean, you could if you wanted to, but personally, for me, I would choose like this really long, like 2x6 plate that kind of extends the whole car. So I'm gonna choose this 2x6. You should be able to just drag and drop if you want, or you can right click and then do insert into current design. They both do the same thing. But yeah, it'll place this block. It'll give you like an opportunity to move things and place it initially. I'm just gonna kind of leave it where it is because I like the orientation and I think it's fine. So I'm gonna press OK. One thing you'll notice is that the first piece you place will always be grounded. So if you look closely up here at the components section, there's a little tiny anchor right next to it. So if you right click it, it'll give you the option to unground it. Please leave it grounded. Basically, dragging and dropping a part into assembly and grounding it, or like grounding the first part, is basically like defining the origin. So when you first create a part, or a drawing, we have this origin here. But when you drag in a component into an assembly, it technically has no reference to everything in space. So the first one is grounded just so it doesn't move. So when you add more components, everything will move relative to this fixed or to the grounded piece. So this is basically like a fixed constraint, but for an assembly. So again, there are use cases where you use the fixed constraint like this, but it's only for this single piece. So yeah. So now that we have this first piece, we can just start adding more and then constraining them. So I'm going to start with kind of like these axle pieces. So there's this, called like buggy wheel piece or something. I'm going to drag it in. And then you can see it's just kind of phasing through the original part we placed. For me, I personally, our goal is to kind of have the piece to be about right here. I like moving it a little bit away from where it's going to be, just so whenever I apply the constraints, it kind of flies into place and I can kind of visually confirm that it's going in the right spot. Kind of like how when I draw things, sometimes I'll purposely like make a line in the incorrect position in a sketch for me to constrain it later. So I'm going to confirm that, and then I'm going to start joining them together. So in Fusion, basically there's a tool called joint, and that allows you to kind of make pieces or components go together. It's a little bit different from other CAD programs that you might be familiar with. So if you are familiar with other CAD programs, this workflow might be a little bit different. But yeah, believe it or not, I personally think that these constraints or these joint tools have gotten better. It used to be a really big pain, but now they're a little bit better, which is nice. When I'm joining two like kind of geometric things, I personally like the between two faces constraint. So I'm gonna set that to both of them. Basically, it'll allow me to kind of select different faces and then have them correspond with each other. So let's say like for this, I want this component to be constrained here and here. And then for the second plane, I want it to be constrained to the corresponding pieces. So for plane 1, I have it as like this one. So I'm going to click that one because it corresponds with it. And then plane 2 should be here. And then it'll ask you for a snap. So I'm going to select like this bottom face here. And then for our snap, I'm going to select this top face. And that didn't do what I wanted it to. All right, let's try that again. Oh wait, sorry. I clicked the wrong tool. It's between two edge intersection. That's my bad. Sorry. Okay. So I'm going to click these two edges, not the two faces. Okay, no wonder that was so weird. And then I'm going to select the two corresponding edges, if it lets me. Okay. There we go. Okay, so I'll do that again. Sorry, I clicked the wrong tool. And my computer's lagging. Great. Okay. Let's try that again. So I'm going to insert this other axle. I'm going to put it in like the general area again, and then I'm going to create a joint. I'm going to select 2 edge intersection. Sorry for the confusion. And then I'm going to select corresponding edges. So the first 2 are going to be on one component. So in this case, I'm going to do this 2x6. So edge 1 is going to be here, and then edge 2 is going to be here. For the other edge 1 and edge 2, I'm going to select the corresponding one. So in this case, because edge 1 is here, I want this edge to be the corresponding one that it goes with. And then edge 2, which was up here, I'm going to select this one. And then you'll see the parts kind of fly together. Oftentimes, it'll just kind of pick one of them and then fly one to the other. And it'll kind of ignore all the other joints you made. So you'll see here that it like kind of flew without regarding these pieces. If you remember, this 2x6 was fixed, so it shouldn't move at all. But when it creates these joints, it'll make them fly. But then once you like confirm it, it'll like resolve it and put it back to where it's supposed to be. So when I press OK, all the pieces go where they should be. Does that make sense? These joints can be a little bit confusing sometimes, so I'll probably just go through a bunch more. Before I go any further, I'm going to add a little bit of extra complexity by saying that you can put assemblies inside assemblies, right? So in this case, you know, there's the kind of body of the car, but then you also have 4 wheels and tires. And when you could manually insert 4 wheels and 4 tires into your main assembly and then constrain them all. But again, you can be lazy and just do it once to 1 wheel and tire, and then insert the whole wheel and tire assembly into your main assembly. So oftentimes we call that sub-assemblies. So I'm going to create one now. So I'm going to open a new design. I'm going to call it wheel subassembly for subassembly. And then I'm going to insert the wheel and the tire. I got the wheels fixed. I'm going to make this tire float. And again, like it kind of places it where I wanted it to be, but I want to make sure I constrain it properly, so I'm going to move it a little bit away. I'm going to add a joint. For round things, I typically like using the simple joint, so I'm just going to click like this edge of the wheel, and then this corresponding edge for the tire. This looks good. I'm going to select OK. So now we have this wheel and tire subassembly. I'm going to make sure to save it, and then we can insert it into our car assembly. Okay, so here we have the subassembly. If I drag it in, you'll see here that it inserts both the wheel and tire, which is what we want. Okay, raise your hand if you need to catch up to this point. All right, that's fine. I'll walk around for a bit. gonna do a couple more. Just 'cause it might be easier for everyone just to see it. I'm gonna add like this kind of console piece here in the back. Let me find it. It's called the roof for some reason. Honestly, not sure why. So I dragged it in. You can see it's phasing through all the components. I'm gonna move it up a little bit, and then I'm gonna add a joint. So the joint tool is here. I know for some people it may not be visible, so if you go under assemble joint, the option should be there, or you can just press J. That's the shortcut. Again, for like these geometric pieces, I personally like using the 2-edge intersection tool for both of them. And then I select 2 edges and then 2 corresponding edges. So I'm going to click this bottom edge here, this other edge right next to it, and then on the piece that I want it to join to, I'm going to select corresponding edges. So for edge 1, which was here, I'm going to click this top one, this top edge right here, and then edge 2, which was this one, I'm going to select this one right here, and then it should fly into place. So I'll do a couple more. I'll add this little front piece here. Gonna add joints, 2-edge intersection. Gonna click these two and these two. They just fly into place. All right. I'll do the wheels in a little bit, but who needs help with kind of like these body pieces?
Right.
It is like
Thank
flexible.
you. Oh my gosh.
Oh, that piece is slightly firm.
Thank you.
Yeah, you too. So okay, the computer's lagging. Okay, for the wheel, you have to be a little bit more careful when selecting um, the kind of areas that you want to join. So basically, for the circular stuff, like I said earlier, I like using the simple joint. But you need to make sure that the area or that whatever you're selecting is actually where you want it to be. So Fusion will like try to predict where you want to join things. So it'll sometimes snap to like parts of your or parts of the assembly that are close to your mouse, but it may not be necessarily where you want it to be. So if you see like my mouse here, you can see those like the blue, green, and red lines coming off of it. It's basically showing you like a mini origin of where you're creating your constraint. So right now it's on my mouse, but ultimately I want it to be centered on the axle. So if I start moving like closer to here on this arc, you can see it snaps to the center, which is good. But if I were to move like a little bit closer to here, you can see that it's kind of snaps to like the midpoint of this arc, right? So this is just kind of something you want to keep in mind. You want to make sure like that the little origin is where you want it to be. So like in this case, like I don't really want it to be here because if I did this and I applied the constraint, I'll show you right now. It'll make like the wheel wobble like extremely lopsided. Um, so you can see here like this wheel is not spinning true to the axle. So that's not what we want. So to fix that, I'm going to make sure that when I click on it or when I add the constraint, it's on the center of the circle. So here it's like not there, but if I move a little bit, it is there. So I'm going to select that. And then I'm going to select this edge here. So you can see it snaps to this like center of the axle. So that's what we want. And when I apply it, it kind of snaps into place. What you may have noticed I did after that is I applied a motion to it. So all of the other parts, they're all rigidly mounted together. You don't really want them to come apart. But there's many options that you can choose from, depending on the constraint type that you want. So if I go into this motion tab, you can see like the standard type was rigid. So all of the like blocks here or the Lego pieces are all like rigid joints. But if I was to change it, in this case to revolute, it'll allow things to spin. So in this case, like, wheels usually spin. So I'm gonna make sure that revolute is applied. You can specify some axis, but usually the default one is correct. I don't really want my wheel spinning this way. But yeah, this looks good. So I'm gonna apply it. But as you can see, there's a bunch of different options for you to choose from depending on your use case. For this assignment, I'd say rigid and revolute are basically the ones that you're going to be using. But if you wanted things to, slide between each other and stuff like that, you can specify it here. Yeah. You can also see that because this wheel was a sub-assembly, like when I was creating the joint, only the wheel part kind of went into the axle, but once I like okayed it, then both the wheel and tire went together. And then again, because it's a revolute joint, I can still spin this, right? Which is kind of cool. Where for these parts, because I made them rigidly mounted, they don't move at all. So that's kind of the behavior for this that we're looking for. These aren't moving because they're all rigidly constrained to the base piece that we created, which has been like fixed, or I guess grounded. It's called grounded for like assemblies. So that's why all of these can't move, which is good. So yeah, I'll do the wheel a couple more times. I should probably add a wheel. I'm gonna spin this around. Then adding joints. Again, for circles, I like the simple joints. Gonna make sure the little origin is where I want it to be. Set it as revolute, and then we're good to go. But yeah, once you have all these pieces assembled, I won't do all of them, but once you have all the pieces assembled, make sure you apply some appearances to this assignment, because I think that is a requirement on the rubric. So make sure it's nice and colorful. Please don't make it all gray, because then I won't know if you added appearances. I think like the steering wheel for some reason doesn't let you apply material, so don't worry about it. But for the rest of them, you should be able to apply it. But yeah. I'll just go over the homework real quick because it's very similar to what we're doing right now. Basically, the objective for your homework assignment is to create your own Lego set. So, we made this Lego car in class, but I'm giving you the freedom to make, your own kind of design. So the requirements is that you need at least 25 bricks. You can use like the bricks that we just used in class, and if I just want 25 bricks. They don't have to be like 25 unique bricks. So technically, if you wanted to, you could stack 25 of the same piece and call it a day. I mean, you could, but I encourage you to try something more creative. Obviously, you want to use joints to make them and assemble it together. But yeah, that's basically your homework assignment. There's a bunch of online repositories where you can download different pieces. I'm just going to show you a couple now. Some of these aren't specifically for Lego stuff, but I want to show you that these kind of things are there. So this doesn't apply to just Lego stuff, but when you're designing things, these repositories can be really nice resources. So one of my favorites is GrabCAD. So maybe not there. GrabCAD library. There you go. So basically, this is GradCAD library is like an online repository where people like upload their designs, right? So you can see there's like some like super random stuff, like scaffolding and stuff like that, like this crutch and stuff. But you know, you can look for things. So if I go like Lego, for example, people have uploaded Lego models. Please don't like take a screenshot of this and send it to me for your homework. But like, maybe I should type in brick. But you'll see here that like people will like, you know, CAD like Lego bricks and then they'll upload it here. So you can use these and you can download them and then you can import them and use them in your assemblies. But for me, I'm mostly showing you this as a resource for stuff outside of this assignment. So when you design things, for example, like you might want to design something that spins and you want a bearing, you can go to repositories like this and then find bearings. So for example, like a skateboard bearing, which is a pretty common bearing that a lot of people like to use for their projects, it's called a 608 bearing. So if you type in 608 bearing, you'll see here, if it loads, there's a lot of different models of skateboard bearings and other bearings, right? So this can save you a lot of time, especially when you're like designing stuff with hardware in it. You don't have to like CAD a bolt because you know most of these like hardware pieces are very standardized. So you can just like download one of these and then use them in your design without having to CAD it. So this is just a nice resource to keep in mind. GrabCAD isn't the only place you can go. For hardware and stuff like that, a place that a lot of people like to use is something called McMaster. So if you go to McMaster, this is like this big, it's basically like an online hardware store where you can buy like basically anything. You can also buy candy here, which is kind of funny. You can buy like Swedish fish if you didn't know in like bulk. So if you really like Swedish fish, you can buy it from McMaster. Anyways, you know, there's a bunch of different hardware options here, but if you find, you know, the exact bolt or nut that you're looking for, McMaster almost always has a CAD file for you to download. So in this case, when you download stuff, I highly recommend you use the 3D step file. When you download them, you can like insert it into your designs. So, I mean, I guess, can I do this? Yes. No. Okay, it's not letting me do it. So once you download stuff, you know, you can upload it to Fusion, just like you did for the other stuff. Once it uploads. And then, boom, you have this nice bolt. Obviously, this is not a Lego piece, but you get the idea. These online repositories are really valuable. So if you ever find yourself designing stuff outside of this class, you might find yourself using these things. Um, so yeah, there's a couple other websites. I forgot like the names of them exactly. I'll send them after class. But they have some pretty good brick repositories. Um, most of these or some of these like CAD libraries aren't really geared towards like Legos specifically. They're just kind of geared towards whatever. So, you may not be able to find the piece that you're looking for. But I'll try to give you as many options as possible. Um, Also, a lot of these websites will ask you to make an account, but most of them are free. If you do have to pay for it, just please don't pay for it and just like find something else, because paying for files is kind of annoying. So yeah, most of these are free. The ones I will send should be free, so feel free to use those. Um, oh, you did? Okay, sweet. So yeah, you can use those to build your homework assignment. Also, apply appearances, please. Don't forget that because that's in the rubric. Yeah. Does anyone have any questions about this? No? Okay. Well, I'll be walking around the classroom for a little bit. But if you think you're done, you're free to go. I'll see you next week. If you have midterms this week, good luck. Um, yeah, I'll start walking around. Yeah. Thank you for coming. Stop this recording.